5.4, day 1 and 2, trigonometric functions of real numbers, periodic functions. In the first example, we're going to use the unit circle in x and y coordinates. And actually, when you get in class, we're going to fill out all the coordinates around your circle. But for right now, just remember that the x coordinate is cosine of theta, and the y coordinate is sine of theta. And to find tangent, remember you're going to take the y coordinate and divide it by the x coordinate. So if you notice, for example 1, a, b, and c, they are all thirds of pi. So if you remember, pi over 3, we're going to use pi over 3 is 60 degrees. So this point would be 1 over 2, comma, square root over 2. So we're going to use this same ordered pair for all three of these examples. So let's look at A. Pi over 3 falls in quadrant 1. Well, in that quadrant, both the cosine and the sine are positive. Sine is the y-coordinate, so that answer is radical 3 over 2. B. 4 pi over 3 is actually in quadrant 3. In this quadrant, the x and the y value are negative. Cosecant is the reciprocal of sine. So I'm going to find the reciprocal, which is negative 2 over square root of 3, and then I have to rationalize it. And that will give me negative 2 square root of 3 over 3. C, secant 5 pi over 3 is in quadrant 4. In this quadrant, the x is positive, but the y value is negative. Secant is the reciprocal of cosine, so that value would be 2 over 1, which is 2. In trig, we have what are called even functions and odd functions. And what that means is, let's use pi over 3 for example. Pi over 3 has the coordinates 1 over 2 and square root of 3 over 2. And if I went to negative pi over 3, that'll put me in quadrant 4. In this quadrant, we know that the x is positive and the y value is negative. If you notice, cosine value did not change. That's why it's called an even function. So cosine of theta, or I should say, is the same thing or the same value of cosine of negative theta. This works the same for secant. Secant of theta is the same value of secant of negative theta. Now look at the y-coordinates. If you notice, your y-coordinates change, which makes the function odd. So sine, which is the y-coordinate, is an odd function because sine of negative theta is equal to negative sine theta. Same thing with cosecant. So if you did the reciprocal, it is also going to be or have a negative value. Tangent, let me separate these. If you do tangent and you know to find tangent of theta or tangent of pi over 3, you would have to divide the y over the x. In the first quadrant, it is positive, but when you do it in the second quadrant, when you do tangent of theta or negative theta, it becomes negative. So tangent is also an odd function. So tangent of negative theta is equal to negative tangent of theta. Same for cotangent. Cotangent is going to change too. So we have two even functions, two odd functions. In example 2, we're going to use what we call even and odd properties to find the value of the same trig function. The values on the left, or the angles on the left, are counterclockwise, traveling the distance around the circle, and the ones on the right, we are traveling clockwise. So for A, cosine pi over 3, remember pi over 3 uses the coordinates 1 over 2 and square root of 3 over 2. Cosine, remember, is an even function, which means the values for A and B should be exactly the same. Cosine is the x-coordinate, so that value is 1/2, which means, because remember this is in quadrant 1, negative pi over 3 is in quadrant 4, where the x is still positive and the y is negative. So that value will also be 1/2. Sine and tangent are both odd functions, so their values will not be the same. 2 pi over 3, since it's in thirds, still uses the coordinates 1 over 2 and radical 3 over 2. The difference is 2 pi over 3 is in quadrant 2. In quadrant 2, the x is negative, but the y value is positive. And since sine is the y value, that answer is radical 3 over 2. But if you go to negative 2 pi over 3, that is in quadrant 3. In quadrant 3, both your x and your y values are negative. Hence why this value, since it's odd, is going to be the negative of part C. E is 11 pi over 6. 11 pi over 6 uses the same coordinates as pi over 6, which are radical 3 over 2 and 1 over 2. 11 pi over 6 is in quadrant 4. Quadrant 4, the y value is negative. To find tangent, we would divide y over, or divided by, the x, which in this case I would suggest you do keep, change, flip. So you keep the first fraction and you multiply by the reciprocal, or flip it. What's going to happen is you're going to get negative 2 over 2 radical 3, which of course we cannot leave like that, so we have to rationalize it. The good thing is the 2's will cancel, and you're going to get negative radical 3 over 3. Well, negative 11 pi over 6 is in quadrant 1, where everything is positive, which means that tangent would be now positive radical 3 over 3. So that's the difference between even and odd. In trig, we have trig functions that repeat in periods or cycles, and that just means they have patterns. And for sine and cosine, no matter where the angle is, it repeats every 2 pi units. So even if it starts in quadrant 1, or if it starts in quadrant 2, no matter what, the cycle repeats every 2 pi or 360 degrees, which means the values or the sine and cosine of those angles are going to be the same. And that goes for cosecant as well as secant. For tangent and cotangent, the cycle repeats every pi units, and it can be from here to here. It can be from here to here, as long as it's repeating every pi or 180 degrees. So the angles for tangent and cotangent, every time they go 180 degrees, the patterns repeat. And for example, if we had to do 45 degrees, it would be square root of 2 over 2, square root of 2 over 2. Even if I go to quadrant 3, if you notice, here, 2 negatives still make a positive when you divide. So those values will be exactly the same. Example 3, we're going to use the unit circle and periodic properties to find the value of the trig functions. So on the left side, you're going to see some of our common angles, and on the right, those angles repeat what A and C do. So for example, cosine of 3 pi over 4. Well, 3 pi over 4 uses the same coordinates as pi over 4, which are square root of 2 over 2, comma, square root of 2 over 2. 3 pi over 4 is in quadrant 2, where the x is negative. And I'll make this dark so you can see. Which means cosine is the x coordinate, so this value is negative square root of 2 over 2. Well, 11 pi over 4, because here's 3 pi over 4. 11 pi over 4 is found by going a full 2 pi units to get right back there. And how it looks algebraically or numerically, 11 pi over 4 minus 2 pi, because that's where it repeats. Get a common denominator. 11 pi over 4 minus 8 pi over 4 gives us 3 pi over 4. See, we're back to where we started. And we already know that value is negative square root of 2 over 2. For C, 7 pi over 4, which now is in quadrant 4, and it uses the same coordinates, but in quadrant 4, the y value is negative. When you find tangent, you divide the y over the x. And when you divide something by itself, you get 1, but in this case, it's negative 1. 47 pi over 4 can be found by doing a period of pi units. So every pi units, so from here to here, from here to here, and you just keep repeating. And what's going to happen is you're going to do 47 pi over 4 minus 1 pi, or 4 pi over 4. And you would keep subtracting until you get to 7 pi over 4. But instead of doing that over and over again, you can just rewrite this as 40 pi over 4, because it'll take us 10 times to actually get there. And that will leave you with 7 pi over 4, which is the same as part C. And we already know tangent of that angle is negative 1.